Oxygen Blast technical seminars are an Intertech production. For instructor-led .NET, Java, and XML courses, visit us at www.intertech.com.
Object association presents many opportunities for what we call impedance mismatch. Objects implement associations with both object references and operations typically. So for example, if we had a customer with a relationship to an address object, we typically provide a property called address, and then we would have inside of our particular class potentially some getters or setters for that address property. And of course, inside of an object world, we actually have the concept of directionality as well. So in our address class, if address knew about its customers, they would have a property called customer, or in this case call it occupant of customer type, that points us back to the owning customer. So in the object world, relationships are garnered from properties and methods that we have in our objects. And the relationship can be unidirectional or bidirectional as shown here. Multiplicity is usually dictated by the type of our properties. In this case, we've got address and occupant both being references to a single object of either type address or customer. But we could easily have those address occupant properties be a list of or an array of addresses or customers, suggesting the customer has multiple address or an address has multiple customers at it. So a collection or an array, as demonstrated here on customer, implies a many type of relationship in Java. Now, how does that translate into our relational database world? Well, with regard to relationships or associations in the database, it's always represented by a foreign key. Foreign keys are always what provide what we call joins from our relational database tables, or for our relational database tables, I should say. And believe it or not, those are directionless. When we talk about a join, in this case between customer and address, we don't really care if we're joining from customer to address or address to customer. From an SQL perspective, it's really all the same. So the concept of directionality really doesn't have any meaning in a relational database. And multiplicity, as far as the database is concerned, that's just the use of foreign keys to implement a many-to-one or one-to-many type of relationship, but uses a link table to establish a many-to-many relationship. So when we're talking about multiplicity with regard to databases, the entire structure of our database, the existence of other tables might be impacted. One other impedance mismatch issue can be seen through exploring navigation in our object graph. Say, for example, we had an object graph where order was associated to account, which was associated to customer, which was then associated to address. If we wanted to know, for example, where to ship the bill for an order in a Java program, we'd have to do something like this kind of call. Now, in a database, a single select statement could really give us the entire set of information. So in a relational database, giving us the answer to where to ship the bill for an order can all be done via a single statement with multiple joins. So a single join SQL query is what we like to say. So as you can see, there are plenty of opportunities for problems, impedance mismatch between our object world and our relational database world. And for that reason, an entire field of software engineering has grown up from this issue, from impedance mismatch. In fact, it's even given a name, the name of ORM, or Object Relational Mapping Technology. This is a technology that hopefully has been built around to try to solve the mismatch problem, or at least make it much, much better. ORM provides transformations between our object and our relational world. Helps allow the database to do things it does well, which is store and retrieve large amounts of data, while at the same time allowing objects to do the things it does well, mimic the real world through our business domain and business objects. So ORM technologies provide tools to bridge the two worlds in order to provide an object state persistence into our relational databases. And hopefully, this technology is done in such a way that it makes persistence something that's transparent to developers. Now, ORM in Java means providing a Java API for performing things like database creates, reads, updates, and deletes. Also, an ability to query and instantiate objects based on query results. Also, we have to think about things like transactions and concurrency when talking about any language, and in particular Java, with dealing with the database. So when we think about ORMs, taking it one level deeper, we have something called persistent frameworks. So an ORM service stores and retrieves objects into a relational database. But from a developer's perspective, we want this to work completely transparently, meaning that as an object developer, we shouldn't have to know all the specifics about the relational database, or for that matter, even SQL. So a persistent framework is something above and beyond an ORM. It's a tool for simplifying the development and the maintenance of our object systems. And Hibernate, ladies and gentlemen, is considered a persistent framework in Java. So why do we need a persistent framework? Well, to avoid things like hard-coding SQL into our Java applications. And indeed, even JDBC and SQL, which allows Java developers to bridge to some extent that object relational impedance mismatch, again as an ORM, they require Java programmers to be pretty familiar with relational databases and SQL. And let's face it, JDBC work is pretty tedious, and it diverts a lot of our attention away from the business logic that we're paid to try to provide. So programmers have to constantly concern themselves with binding query parameters, writing SQL, executing queries, getting things like connections. All that's part of the JDBC SQL work. And while it does help to bridge to some extent, again, those impedance mismatch issues, not always the best means for us to try to get things done quickly. As a matter of fact, again, somewhere between 30 to 70% of our time is typically spent in this kind of work. So persistence frameworks help alleviate this ORM impedance mismatch. A persistent framework helps make coding faster and helps improve maintenance. It also helps to isolate those application database specific intricacies. For example, if you've ever worked with Oracle or DB2, you're probably aware that while there is an SQL standard, not all SQL is absolutely generic. In other words, sometimes SQL is specific to a particular database. And should the boss decide that we're going from Oracle to DB2, in some cases that could be a real impact to our applications and having to rework a lot of that SQL. Or even if not the SQL, having to rework a lot of particulars around how to deal with things like transactions and concurrency. So finally, a persistent framework, in addition to these capabilities, can also, in some cases, help to actually improve performance. That's typically because a persistent framework knows how to take advantage of things like caching and some of the intricacies of those particular databases. Now, Hibernate was created all the way back in 2001 by a gentleman named Gavin King. He developed Hibernate to try to meet the needs of what he saw as deficiencies in EJB. He saw that what was known as container managed persistence, CMP EJBs, didn't scale very well, and they were really way too complex. And this is an opinion shared by a lot of the Java community. So right up front in the product documentation of Hibernate, you'll read that Hibernate's goal is to relieve developers of 95% of all common data persistent related programming tasks. Now remember, folks, when we talked about how our work is sometimes 30 to 70% of our time is spent dealing with relational database to object issues. So imagine if we can get 95% of that back. That's one heck of a lot of project time back. Hibernate is an open source framework, and particularly an open source persistent framework. It's now part of the JBoss community. Hibernate also, believe it or not, supports EJBs today. In fact, EJB 3. It is actually an implementation of the persistence part of EJB 3. In fact, Gavin King helped serve on the board as the EJB 3 specification was reworked. Hibernate is available from hibernate.org. All the project documentation is available on that same site. And the focus of our class here is going to be on Hibernate 3.3, which again, available from hibernate.org. Now, in case you're thinking that Hibernate is the only persistent, or for that matter, ORM framework, there are actually many persistent frameworks, many ORM options in Java. Of course, as I mentioned, we've got things like EJB, but we also have things like JDO, Java Data Objects, Spring DAO, and some other open source projects like Castor. We also have some additional commercial products, things like Toplink.
For more free learning resources and to see the latest lineup of our instructor-led .NET, Java, and XML courses, visit us at www.intertech.com.